is being recorded, and you'll be able to watch it again on the ASPIS YouTube channel. So today we are looking at the ONTOX and the VHP4Safety IT platforms, and we will have Ozan and Jörg. So Ozan is a postdoc at Maastricht University and is representing VHP4Safety, and Jörg is the Chief Technology Officer at MNAM, and also the Chief Technology Officer for the sustainability of ONTOX. So he's representing, obviously, ONTOX, and this webinar is organized in collaboration with the ASPIS Academy. So a quick introduction to both projects. VHP4Safety is a Dutch research project. It's funded by the Dutch Research Agenda and coordinated by Utrecht University of Applied Sciences, and the RIVM, and it's running since June 2021 and until May next year. And ONTOX is a European research project funded under Horizon 2020, coordinated by Vrije Universiteit Brussels, and is running roughly around the same times, so starting 1 month earlier and ending 1 month earlier as well. So it made sense to have a collaboration between ONTOX and VHP4Safety, since they have a common goal of advancing human risk assessments, either without the use of animals or with reducing at least the use of animals. And the first meeting of this collaboration happened in October 2022. The 6th collaboration group were formed in 2023, and the memorandum of understanding was signed in February 2024. So the collaboration group, we have 6 of them: research output management, stakeholder involvement, quantitative AOPs, chemical selection, IT platform, and risk assessment. And this webinar series is focusing on each collaboration group. So we'll have 5 in total, because we skipped the chemical selection group, which is not very active. But the first 3 webinars have already run, and you can watch them again on the ASPIS YouTube channel. The aim of that series is to focus not only on the collaboration between ONTOX and VHP4Safety, but it's also a platform for early-stage researchers to present their work. That's why it's also in collaboration with ASPIS Academy, which I will mention in the coming slide. And we organize this approximately once every 2 months. So the final webinar will likely be at the end of November or early December. Now, ASPIS Academy, it's a network for early-stage researchers that are involved in developing and using new approach methodologies in toxicology. So it's about networking, boosting the careers of young researchers, and it's specifically developed in the scope of the 3 Horizon 2020 projects: ONTOX, Risk Hunter, and Precision Tox. And what we are doing is we have a training program where we give, or we organize rather, in-person training. So for example, ASPIS Open Symposia, we organized a summer school earlier this year. We organize workshops on soft and hard skills. We organize career development sessions, all of that. We have a few people involved, so early career researchers from all 3 projects. And we also have a board with members from all 3 projects as well. And if you are interested, you can join the ASPIS Academy LinkedIn groups. Then you will be also kept updated about the events that we organize. Now, for today, we will be exploring the IT platforms. And here I left, Marvin was going to present with Ozan as well, but he's unable to today, but I know that they've been working closely together. So I will give the floor to Ozan to present the IT platform of VHP4Safety. Ozan.
Thank you, Marie. I will share my screen.
Oh, maybe just while you set up, we will have time for Q&A at the end. So of each presentation, if you can put your questions in the Q&A, then we'll address them afterwards. Thanks. Go for it, Ozan.
Thanks, Marie. And just for checking, is my screen visible to you?
Yes.
Okay. Okay, good afternoon, everyone. My name is Ozan Çinar. I'm a postdoctoral researcher at the Department of Translational Genomics at Maastricht University. And I work under VHP4Safety, and I work on the IT computer infrastructure of the platform. Marie explained a little bit, but I also want to do an introduction to our project. So VHP4Safety is a project to conduct risk assessment of chemicals and pharmaceuticals. The common practice nowadays is to utilize in vivo data from laboratory animals. However, there are some criticism on this approach because its accuracy might be limited, and also it's not easy to reflect some of the human-related scenarios in laboratory animals, such as age and disease state. An alternative to this approach is using in silico data from human, and this is also considered to be improving the accuracy of the safety testing due to that previous criticisms, and also it may be preferred more because due to ethical reasons. And in brief, in VHP4Safety, we aim to create a platform, an online tool to present tools and supplementary material to conduct risk assessment through human-based data without using laboratory animals. In VHP4Safety, we have three research lines, three pillars of the project. The first research line is focusing on building the platform. The second research line focusing on the feeding the platform, and the last and third research line focuses on the implementing the platform. And under each research line, there are multiple work packages. And I work under the work package 1.1 under research line 1, and our goal is to build and maintain the computer infrastructure of the platform. So to begin with, our platform is available at the moment online. So you can find it on the platform.vhp4safety.nl. And also as a side note, we also call this platform within the project as central access points, or CAP in short. So I put this note because you may see the term CAP in some of my slides, but it refers to the platform. And our platform has two main sites: the front end, the website that you see when you go to that link, and also the backend, which is the background of platform. So this and the computing part of the platform, which does the platform. And I'd like to give a brief information about both of these sites. So I will start with the front end. This is what you see on the web page. And on our platform, we approach this problem, risk assessment problem, from an approach of workflow. Workflow is referring to a series of tasks to achieve the main goal, and all of these tasks may be associated with computer tools, or more than one computer tools. And in general, our researchers in the project found out that a general workflow on risk assessment consists of 6 steps, starting from hazard and ends with the adverse outcome. And in our platform, we want to follow this approach. And also to do so, we actually present 3 case studies as demonstrations to apply this risk assessment. And all of these case studies are available at the link, which you can reach from the platform as well. We also have a specific work package in the research line 2, focuses on each of these case studies. And also we have presenting 2 exemplary regulatory questions for each case study. Our researchers also came to the conclusion that actually not all the steps in the main workflow for risk assessment, main 6 steps, may not be relevant, or maybe may not be applicable in these specific cases. Therefore, they also work on creating a specific workflow for each of these case studies, which we call as process flow. And the steps within this process flow called as process flow steps. For instance, for the thyroid case study, we have external exposure kinetics, adverse outcome pathways, and adverse outcome. So skipping the hazard and internal exposure. And researchers also try to present these process flows in a diagram. Due to the nature of these diagrams, they are quite large diagrams, so it's very difficult to present them in a slide. But if you want to see them in more detail, you can reach us and we can provide these diagrams to you. And those diagrams, you can see that there are multiple multiple layers. So on the top, we have the blue boxes, the main steps of the process flow. And under those, we have the light green boxes, which explain the main tasks in those. Smaller tasks to complete to risk assessment for this case study. And down below, we have blue lights, which explain the tools that can be used for these steps. And the tools can refer to maybe program, software, or maybe data sets. So if you go to the case studies and if you select a case study from the platform, you will be starting to interact with the platform, and by clicking on these blue boxes that you see on the platform, and then it will show you the steps that you can follow for this case study. I also need to explain that this is a work in progress, so not all the steps are complete at the moment, but we are aiming to complete them as soon as possible. So here, as an example, you see the thyroid case study. As I mentioned, there are two regulatory questions for each of these case studies, and you see two regulatory questions. And then you can start interacting the platform by clicking these buttons. So for instance, here I clicked on the second question, and there you can see that four main categories or main process flow steps that we can follow in this to answer this risk assessment question under this case study. And when you select one of those again, you can go to more detail. So you are going layer by layer. So if you click on AOP, you will see the steps in this case study, steps in this flow. And if you select one of them, for instance, I select AOP development, and then you can see what tools you can use for to complete this task in this process flow. And in addition to the case studies, we also provide a list of tools, a catalog of tools on our platform. It's another section on our platform. And in this section, we present a list of tools that can be used for answering these risk assessment questions. Those tools have been recommended us by the project partners, and we collect some metadata about those tools so that you can find them and you can reach them and you can use them. We also here provide a filtering functionality on this page, so you can use these filtering options to specify your search. For instance, if you are looking for like tools that are used for admin, then you can do this filtering here. Or if you want to find the tools that are used for a specific regulatory question, then you can use this second filtering. And I will come back to this later. And here we present a general image of the tools or software that has been developed by the members of the project during the project, or some of them had already been developed before the project starts, but as they are also internal members, and we are also glad to share them, and we are also glad to provide an instance for them under the VHP4Safety. So this was the front end. So this is how you can interact with the platform through that web page. And in the second part of my talk, I want to talk about the backend of the platform. And this is what's happening behind the platform, and this is how we maintain and develop our platform that you see on that web page. The project aimed to have a sustainable platform, which means that they want it to be easy to store and maintain. And if we want to recreate or relaunch that platform, they want to do this without any difficulties. And in addition to this goal, sustainability goal, we also set a goal within the work package, within our work package as like a personal goal, which is the reproducibility, which refers to that even after the project ends, we want our platform to be relaunched by anyone else, anyone who wants to use it, and we want them to be launched the platform without any difficulties, and in the exact form that we have now. Therefore, this and also I can also mention that sustainability and reproducibility are also common goals in scientific research. Especially reproducibility might be a goal in your scientific research. For instance, if you do an analysis, and then if you want to repeat your analysis maybe 2-3 years later for a conference, for instance, and if you want to reproduce all your results, then it comes to the goal. It does come to the theme of reproducibility, and it may not be always possible to reproduce your outcomes because the software may have changed that you used 3 years ago. But we also want to, again, as I mentioned, we also want to be able to reproduce our platform even after the project ends. To do so, we mentioned we use a couple of softwares, and I also wanted to introduce them to you. I don't know the exact demography of the audience, but maybe some of you are early researchers, and or maybe even you are not early researchers, maybe you are not familiar with the software, and maybe you can find some use in these through my talk. So we use 3 main software for this. We use Git, which is used for version controlling. We use this for keep track of our development and changes that we did in the product. And it also allows us to make a collaboration and working on the same product at the same time from different partners. The second software is Flask, which is a Python module, in fact, and we use it to create an interface to our platform. And the last software is Docker, which is a software for containerization, which is used for taking a snapshot of a program or of your project, and then you can keep that container as it is for upcoming years or upcoming time. Then you can reproduce all your results in the same form that you had them in the past. So I like to go through these software one by one. And this will also explain what we are doing actually in Work Package 1.1 in terms of this platform. I like to start with the Git and GitHub. So you may be familiar with the term GitHub. It's an online service, but in fact it's kind of like hides the reality because Git is in fact an standalone software which is available on the main operating systems. So you can use Git locally on your computer. So you can create a project, for instance, for your thesis, and then you can keep your changes in your thesis one by one in your local project. And those projects in the Git terminology are called as repositories. So you can create a local repository with Git, and then you can keep track of your changes that you did in your project through Git. And each of these versions or each of these different the changes that you made in your project are associated with a unique ID. And this is useful to go back into a state of your project that you had in the past. If you think that, for instance, some of the new developments that you did in your project maybe did not work well, so you want to go back to an earlier version. So with Git, you can do this through this unique ID that you had for that previous version. And Git is also supported services, enables the local repositories to be shared online, and it also allows multiple collaborations to work on the same repository, on the same project at the same time. And also it allows the merging of contributions from different parties. For that, we are using GitHub, and GitHub is also like open to everyone. So you can create a free account. And if you go to that link, github.com/VHP4Safety, you can find our organization there. And you can also find our repositories under the organization, and we have multiple repositories for different tasks. For instance, we have the glossary repository where we keep track of the terminology that we use in the project, and we describe them to have a consistency among our conversations in the project. Another repository is Cloud, which is where we collect the metadata of the tools that we have seen before in the platform. Or AOP app is another repository. And this is a repository where one of our members of the project works on development of AOP Network Builder tool. And finally, the last example that I show here is WP 1.1, and this is also a private repository. So this is also another functionality that you can get with GitHub, and you can keep your repositories private if you don't want to share them. And WP 1.1 is a private repository, and this is where we archive and document our work in Work Package 1.1. We also develop our platform as a repository on GitHub. We call it UI Design repository, which is also public, and you can find the repository at the link that you can find on this slide. So if you go there, you can find the source files, and all the repositories are also associated with the README files to explain what you are doing with that repository. So here in that README file, we explain what we are doing with that platform or that application and how you can install it on your own local machines. Now I'd like to go through a couple of functionalities that we have on Git and GitHub that will hopefully help me to explain you how we can use this version controlling and how we can get reproduce our previous results with Git. The first functional that we use in Git and GitHub is the issues. So you can go to so every repository have their issues section, so you can go there, and then you can. Everyone that has a GitHub account, of course, and that has know the link to this repository can create an issue on GitHub to give us feedback or requests or maybe report bugs. Within each of these issues, there's a place where you can explain and also communicate with others. So, for instance, here you see an issue that I created, and I put some explanation about what I want to do with that issue. And then I'm communicating with other members of the project to discuss what we need to do with this issue, how we can deal with it, how we can address it. And then we can also give links to our developments within these issues. And once an issue is completed, then we can close the issue. As you can see here, UP has closed this issue. And the important thing is that Git and GitHub follow a track of these closed issues as well. So as you can see, we have closed 33 issues so far under the UI design repository. And these are still stored on GitHub's dashboard, so that we can, if we think that there is a problem with one of these solutions, then we can reopen an issue and continue discussing to solve that or address that issue. Another functionality of Git and GitHub is the forking, and this helps us to collaborate. So here you can see that I'm forking the main repository, and by doing so, I create my own fork of this repository, and this is where I can do my developments on the platform. So I can do my work on this platform, and if there's a change on the main platform, on the main repository, I can also sync my repository based on them, and I can work on my development. And after finishing my development, I can send my developments or my work back to the main repository. In this image, you do not see that there's a work that I sent back to UI repository because I didn't have one at the time, but I can send it. And once I send it, it becomes a pull request, which is also has a similar image or similar functionality as we saw in the issues that you can. For instance, here you can see a pull request made by Egon, who is the co-leader of our work package. So he did some work and then he explained it to other people. So maybe here, for instance, he explains what he did to Anik because Anik was probably asked to make this change. And also more importantly, you can also see the changes that are made in that development. So others can also review what has happened in that development by that person. So for instance, here we see that some of the text in the landing page had been changed by Egon, and then we can also review that changes by others. And once the pull request is accepted by everyone, we can commit the changes. And again, the commits, you can see the commits here, all the commits that have been made in the past. Not all the commits are done through a pull request. So here, why you are seeing more commits than the number of pull requests. And also importantly, again, all those commits are given a unique ID if you go into them, and we can go back to an earlier version. So for instance, if you find out that there was a mistake in one of our latest commits, and if we want to reinstate an earlier version before that merge, then we can go back to that earlier version using its unique ID. We also use Git and GitHub for storing our metadata for the tools, as I mentioned, in the cloud repository. So here, where we are collecting metadata about the tools, and we are collecting those metadata in JSON format. So we have a consistent template for doing so. So we are asking a specific information from all of these tools. And we keep them as like this. So for instance, we have a name for the service, a description, and also links to, if there are links to introduction or documents, have supplementary documents if there are. And this brings me to the last functionality that we use from Git and GitHub, which is the GitHub Actions. And these refer to some work that needs to be done routinely. So for instance, here in the cloud repository, what we do is that whenever we make a change in the metadata of the tools, it runs a specific action, which we call as a collecting service metadata for CAP, which is platform. So, and whenever we make a change in the metadata of the tools in one of these JSON files, we want to update our file, a file called service index, which is used by the platform. So whenever you go to the tools page on our platform, it's actually content is coming from this outside source, from the service index JSON file that we keep outside of the platform. And this helps us because with this manner, we can change the content of our platform without making updates to the platform, because making updates to the platform requires a maintenance time, or we need to take down the platform. We need to take the platform down for a while. But with this approach, we can update the content of our platform without changing the platform itself. So the content is coming from outside. And we also follow a similar approach for the case studies section of the platform as well. So all of the content that you see at the case studies section of the platform is actually stored somewhere else. And we can we can make the adaptations, or we can make the developments on the content of those case studies in that outside source. And that helps us to update the platform without taking down the platform. So this was the end of my part of the Git. And the second software is Flask that we use to create our platform, which is actually a Python module to create an interface to Python programs. So actually, our platform is actually written in Python. So it's a Python program. And then we create this interface that you see and interact on the web page through these Flask applications. And all of these actually are also available under the UI design repository. So actually, if you go there, you can also see our source code for the UI design for our Python program, and also how we create the interface for the program. In this Flask approach, we actually follow a similar approach that we use in Python programming. So we have this main Python script, and you can see that it's actually a casual Python script. And we need to do that because we need to use this Python, or actually program behind that, because our platform needs to respond to the requests of the users. Because, for instance, if you go to the tools section, and if you want to use the filtering functionality there, you are making a request to our Python program, and to our platform. The platform takes it, and the Python that is running in the background responds to your request, and then does the filtering in itself, and then send it back to an HTML file, again, which we have in the Flask app, and it creates it renders the web page that you see on your web browser. And this last software that we use is Docker. And the Docker is a software to containerize collection of software and programs. And this is useful for creating a container, creating a collection of your program or of your project, for instance, or of your any project. And you can also include the prerequisites in that container. For instance, if it may also have happened to you. For instance, you may do an analysis in Python or R, and then you share your analysis with your script with your supervisor, for instance, but your script doesn't work on their computer because they don't have the libraries for R libraries or Python modules. With the Docker, you can create a snapshot of your program, of your script with all the prerequisites, and then you can share it, and then it will be reproduced by everyone else that you share your container with. Therefore, in that sense, a Docker container is a self-sufficient collection to run a program without installing the prerequisites on someone else's computer. In that manner, they resemble to virtual machines, but Docker containers are also known to be much more lightweight than the virtual machines because they do not install their own operating systems with them, like virtual machines does, or virtual machines do. And Docker is also available on the main operating systems, Windows, macOS, and Linux. A traditional workflow in Docker is that we collect our program with the prerequisites locally, and then we create that image. It's also known as image. So we create this image of that container, and then the image can be shared online. So for instance, Docker Hub is a common repository where we can share, where we can put our Docker images online. We don't do this in our project, but it's possible to like share all of our versions of our platform on Docker Hub so that anybody who wants to get it can get it from Docker Hub and install it easily, which we can also done through our GitHub repository. So that's why we don't do that in our project. And it's also possible to launch a container on locally and expose it to the internet. Therefore, it will be available to everyone else or that have an internet connection. And that is the approach that we follow because we want our platform to be findable by other people. So if you go to that link, you need to find our program, which is stored as a Docker container and exposed to the internet so that you can find the content of our Docker container. We also have this Dockerization on our UI design repository. So we have this Docker file there, which is a common one of the ways to create a Docker image. So as you can see, we have the Docker file here. We run it on Python, and as you can see, we run some dependencies. So if you want to run this, normally, if you want to run our Flask app on your own computer, you will need to install these dependencies on your own computer manually. But with the Docker, you do not need to do this. So you can get the container with all the requirements in it. And then we launch this container on a server. We get a server from our server is provided by Strato, which is a company based in Germany. And on the terminal of that server, it looks like this. So this is how it looks actually. Our containers running. So not too fancy, but it's running there. Finally, we also do this Nginx configuration on the server, so that you can find our web page you can find our container with the app inside of it on that specific web page. And as you can see, we can also create different versions of our container. So as you can see, we have different versions. We keep all the versions on the server, so that if we find out that there is a mistake in the latest version, then we can go back to an earlier version. And we also keep a version log on the UI design repository, and you can find it on the following link. We also use Docker for the tools that we develop. So most of the tools that you have seen before in that large image, actually they were all Docker containers. So for instance, we have this QSPR-Pret tool that is also developed as a Python program with Flask. So we have this as similar as a platform. It's also possible to Dockerize or containerize the RShiny apps. So OPK model is another tool that is developed in the project, and it's developed as a RShiny application, but it's also possible to Dockerize them and expose them on the internet. And also, for instance, we can also create tools, HTML-based APIs, and then we can also Dockerize them and expose them on the internet. So Docker is also a general way for us to develop our programs in a reproducible manner. That brings me to the final slide of my talk. So we talked about the front end of the platform. So we present case studies there on the platform in order to demonstrate exemplary risk assessment workflows, or in our cases, process flows. And we also present a list of tools that can be employed in risk assessment. On the backend, we use Git and GitHub for version controlling of our files and of our work. We use Flask for developing the app itself or the platform itself, and we use Docker for containerization and expose our platform on the internet. And particularly Git and Docker, as my main message, is that are quite useful tools for sustainability and particularly reproducibility. And these are also open and free tools, and you can also use it on your own, and you can also use it on your own projects to have to add some reproducibility on your own work. With that, I thank you very much for your listening. If you want to reach us, you can reach us from the project's mail address, VHP4Safety@uu.nl. If you want to reach me personally, you can use my mail address. Or if you want to already start adapting into the Git way of research, then you can also reach us from the UI design and create an issue on our UI design repository to give us feedback or questions. With that, thank you very much, and I give the word back to Marie.
Thank you, Ozan. Very nice. Do we have some questions for Ozan? You can either put them in the Q&A or you can raise your hand.
I think someone said something in the chat.
In the chat. Okay. Julia, this is very interesting information. Thanks for your presentation. Are these tools and project flows chemical specific? For example, this is the use case mostly regarding smaller molecules or other chemical types like biologics. Following from that, do they fit into EU regulatory requirements for each type of chemical?
I can partly answer that question, and and maybe other members of the project may give more details. But at the moment, I believe not all the regulatory questions, are specific for a specific chemical structure or compound. But we are working, or colleagues in other work packages or in research lines are also trying to specify those questions on specific compounds. And in terms of EU regulatory requirements, I actually don't know that information, and maybe I can give that information to, or I can relay your question to our project members, and they can reach you. So unfortunately, I don't have that answer. I'm sorry.
Right. There's also a question from Chris. I understand how you can redeploy individual services in containers, but what about the whole platform?
Yeah, so in that manner, yes, the platform itself is also kind of a tool. And if you want to reproduce all of the services, you would need to launch all of these services and their Docker containers as well. In that sense, you're right, Chris. So relaunching the whole platform is not just relaunching the platform, the container of the platform. But that's why we also create documentations about how we can deploy the other tools. So and these are available in that private repository in the work package 1.1 in WP 1.1 repository, which have documentations to explain how you can launch those single tools. And once they're all launched, then you will have also a reproduce tool or reproduce platform. But yeah, it will require additional steps to launch all the individual tools that are listed in the tools page.
All right. I don't think we have other questions in the chat or Q&A for now. In the interest of time, I would suggest that we move on to Jörg, and then if you have more questions for Ozan, just type them in the Q&A or in the chat, and then I'm sure Ozan can answer. Jörg, floor is yours.
Thanks, Marie. I'm trying to share my screen. Can you see my screen?
Yes.
Okay, thank you very much. Thanks for the opportunity to present here today. My name is Jörg Marusczyk. As Marie introduced before already, I'm CTO for Molecular Networks Altamira, and I'm also working as CTO for ONTOX Sustainability. Now, sustainability in general is a big topic in ONTOX, and I want to start out with this slide here. So it basically gives an overview of all the things we can choose from. So it shows a snapshot of possibilities We have various different things developed in ONTOX. So there, for example, is BioBricks, TOX Index and TOX Transformer from Thomas Hartung and Tom Lüchtefield that bring in AI side. There is BioStudies and SysRef that brings in documentation and publications. We also have a GitHub repository with some things available on there. We have training and education provided also within the consortium, so that's something we can utilize. And then on top, we also have links to other projects, for example, Namastox with Risk Hunter, or now SysRef. So there are lots of opportunities for collaboration. And what we're trying to do with the ONTOX Hub to bring all of that together, not necessarily everything, but part of it together in the ONTOX Hub to provide a sustainable platform that can be available after the end of the project. So in short, from all the things you've seen here so far, what's in the ONTOX Hub? So it's on one side, it's in silico tools and applications like physiological maps, ontologies, predictive models, AI systems, but also the so-called OPRA approach. So that's the ONTOX approach for probabilistic risk assessment, which basically outlines a workflow how probabilistic risk assessment can be done. But besides these in silico tools, there are also a part of ONTOX in vitro tools. So there's in vitro testing and lab services that are done within ONTOX, but that we could also envision being marketed through the ONTOX Hub in the future. At this point, I want to bring up a couple of words about ONTOX Hub marketplace and exploitation. So in order to facilitate exploitation and sustainability of the ONTOX project results, we performed two tasks. First of all, right at the beginning, we started out with an analysis of partner IP and external market analysis. So we took a look, like, what's the IP that is available inside the consortium? Are there any potential IT sensitive topics where partners inside the project would be willing to share IP or not? But then on the other hand, the external side, what's currently on the market? So M&AM has been active in this field of computational toxicology for a while. And in that position, we have quite a good overview because we are also active in this business. And based on this internal analysis and the external market analysis, we're trying to develop a business and sustainability strategy for the project results. In this context, I would also like to mention what does exploitation and dissemination mean in the context of Horizon Europe. Because whenever you say exploitation, people normally think right away about money in some way. You have a service that you charge for, but that is actually not necessarily the case. So education and training can be one of the ways to exploit project results. Open science initiatives that profit from project results are another thing. Then there could be third-party uptake with private investment after end of the project. So that's a little bit the direction into which we are going. And then, of course, one of project results could also be enhanced communication and engagement with public, including dedicated activities for visibility, use, and valorization of results. So that basically means that after the end of the project, something stays available online for the public to engage with. In summary, exploitation is not necessarily by exploitation by commercial means. Of course, it's always good to have the commercial side, because whenever you want to provide something after the project ends, for example, a service that will keep running, it has to stay on some server. Server hosting is not for free. So therefore, if you can generate some income from the project to keep some software platform running, that's always a good thing. So in order to facilitate this, one of the results of the market analysis we did is that we would suggest for the ONTOX marketplace a so-called tiered approach. So tier 0 would be public access, so public tool and knowledge implement in the ONTOX Hub can be made freely available, free of charge. So that means very practically there's a website where you can go, where you can take a look at the project results, can use some of the tools that are available, and it's just free of charge. Tier 1 would be commercial access. So commercial access means that commercial tools with partner IPs implemented in ONTOX Hub could be made available for a certain fee that of course has to be agreed on with the ONTOX partner that is providing that kind of IP. Then as tier 2, we could envision commercial testing services. So I mentioned before, in ONTOX, it's not only about in silico, but there are also lab service testing services involved. So one thing we could envision would be a fee-based access to in vitro testing and assay data that would be performed by project partners. And then finally, tier 3, consulting services, which is fee-based expert knowledge and consulting. So that basically would include all the things above. So consulting services could be that a consultant goes in, uses the tools to the problem a potential customer has, so the software tools that are available, but also on the same side, uses not only software tools, but also utilizes testing services that we could offer. Now going a little bit more technical. So in order to facilitate such a system that we outlined now from a business perspective, more or less, what would be the technical requirements? So one technical requirement we have for sure, and it's similar what Ozan mentioned before. So what we do should be based on open source tools that are publicly available, and also the same thought that Ozan mentioned before, using a containerized environment that facilitates or allows the use of Docker containers is certainly the way to go today. Of course, when you want to provide access to a system that is not only completely for free, but also wants to offer paid services, you also need some kind of access management. So not everybody can use all the services because there are services that potentially would be paid for. So in order to facilitate that, you need some kind of open source identity and access management. That means when you go to the website, you would have to log in to get access to a certain service. Then whatever we do, it should be deployable on major hosting platform providers, for example, such as Amazon, Microsoft Azure, DigitalOcean, OpenShift. And this is simply to avoid vendor lock-in, meaning you build a system that you will have problems later on to migrate to another hoster. And nowadays, the world, unfortunately, is moving into that direction, that every hoster tries to make your life very easy by offering specific tools that helps you build great things, but that on the same side totally keeps you with that hoster and avoids that you can easily move to another hoster. And then another consideration was working together in a, let's say, distributed development team across the European Union, but potentially also distributed across continents. We also wanted to have a solution that provides a self-deployable environment for project partners. So individual partners could go in and update their service in the ONTOX hub without affecting the rest of the system too much. On top, we have a couple of additional requirements. So ONTOX hub should be hosted inside the European Union for the time of the project at least. And of course, we have to adhere to GDPR compliance. So everything regarding use of personal data has to be GDPR compliant. As my summary of this slide here is that the choice of technologies you do should also be made in a way that it facilitates and supports potential exploitability in the future. Now let's take a closer look of what the technical infrastructure of the ONTOX hubs actually looks like. So Ozan mentioned Docker containers as a nice way to exchange software components, deploy software components across different systems before. We actually, for ONTOX hub, are settled on a very special Docker environment called Kubernetes. Kubernetes was introduced like more than 10 years ago by Google. And it basically provides a cloud environment, a standardized cloud environment that is open source to deploy Docker containers and run Docker containers inside that environment. There are a couple of advantages compared to using plain Docker that just runs on a single computer. So when we take a look at the usage pattern of software systems in our area, I mean like computational toxicology, then I guess it's roughly across different software companies, it's always the same. It's a very sparse usage pattern, meaning you have a server that does most of the time nothing, and then you have a user or several users that come in, run a data query, run a computation, and then suddenly your server becomes very busy for like, I don't know, depending on how the computation runs, minutes, hours, or a day. And then your server is sitting there again, doing nothing for the next week. And that's just a fact because there are not too many, the user groups in general in computational toxicology are not that big. And so you end up with that usage pattern. And in order to support that better, it's good to have a system that allows, to a certain extent, dynamic scalability. So that means when a request comes in and the system realizes that tasks cannot be worked on in a timely manner because there are 2 or 3 people just by chance accessing the server at the same time, you might want the capability to scale up your environment, so to provide more computational power for a limited amount of time until all the workloads have been served, and then afterwards scale preferably down again. And this is simply to be more cost efficient. And such a setup is not easy to realize, but it's still doable in a Docker and Kubernetes environment, and it's simpler to implement in a Kubernetes environment than in a plain Docker environment just running on one server. Because in Kubernetes you can relatively simply add additional nodes, and a node in this context is just basically another computer, and you can move them in and out, and but you don't have to worry about the details of the hardware of starting a server or whatnot. Yeah, then I mentioned before we might want to offer commercial services, so we need some user management. Choice for user management was is relatively easy nowadays. There is one standard component called Keycloak, which does not only provide user management, it also provides additional features like user self-registration by email, or it provides binding to LDAP, potentially available in companies, or it provides things like OpenID Connect or SAML authentication, which are just standards that are nowadays used, for example, when you log into your Microsoft account. This uses SAML or ICD as login. And these services or these authentication services, you can very easily bind to Keycloak, and by that also get in users that are actually managed somewhere outside our system. So potentially nowadays there are 3 different types of users. So there's the end user, which is the toxicologist that wants to use the system and wants to run the service. But then on top of that, there's also the developer who might be updating services, improving things. And a third potential user is actually a robot, so programmatic access via API. In the future, most likely also for consumption or for binding large language models to such an environment. And in order to bind the user management together with the ONTOX HUB containerized Kubernetes environment, there is an additional component, what we call an access gateway. At the moment, we are settled for a commercial component on this one called Ambassador, but it's really only because 3 years ago when we set up the system, this was the easiest way to do that. In the meantime, technology has moved forward, and there are other ways actually to do this entirely based on open source components. So now when the user enters the ONTOX HUB, the first thing they see is the dashboard. So it's just like the entry page where you see all the features that are available. Then there are links to marketplace area, so where you the computational services, the lab services are announced that are available. And there is also data available from the ONTOX HUB, and one of the special things we try to take care of is that data as well as models, they could be either hosted inside the ONTOX HUB, so deployed in a Docker container running inside the ONTOX HUB, or we could bind them via API and be hosted outside the ONTOX HUB. And we kind of have both scenarios available in ONTOX HUB. For example, we have the Cosmos database running right, or a specific version of the Cosmos database, it's enriched with ONTOX data, running right inside the ONTOX HUB. So I'm not sure if I'm running out of time now. I'm just going to keep going. A couple of components we have available in the ONTOX HUB so far is, I just mentioned it, the ONTOX Cosmos database. Then we have a summary search to search this database. And we have a model applier that basically runs the different models that are developed by partners inside the ONTOX consortium. Some of these models are run inside the ONTOX HUB, other models are run outside. So actually in the US, so are connected over the internet. I just want to give you a very quick look how this then looks in practice. So that's the dashboard of the ONTOX HUB. We have the summary search here, and you can just enter a search term. You see some data that we found in the ONTOX Cosmos database. I click on that compound, and then it takes a moment and hopefully shows up fast. Yep. And then you see some summary information, high-level information that we have available on this particular compound. And you can also go down a little bit further, and there are also prediction services that are run out of the box. For example, Vega predictions. So part of the platform in ONTOX to implement new models is Vega, because it provided an easy out-of-the-box environment to implement new models. And we try to make some of these calculation services that are implemented by project partners available here. Then we also have the model applier. I just want to go in here really quickly. So this is basically a more specific platform to run models. Again, we have now all the Vega models that are available in Vega and are developed by partners available in here. And just by selecting the endpoint of interest and uploading a structure file, chemical structure file, SD file, you can start a task, and this task can be actually longer running. We try to support bigger data sets. So once the computation is done, you will be notified about the end of the computation in the list of finished tasks here. Continuing with the presentation. So what are the next steps that we have currently planned? One thing is integration of Maastricht. That's a tool that's been developed in Risk Hunter, and the other thing we call LLM readiness, make ONTOX models and ONTOX HUB available for LLM, so large language model consumption. So to take a look at that a bit more in detail, so Maastricht is guided approach for interactive NGRA workflows developed in Risk Hunter to support their what they call ASPA workflow. That's similar to the Opera approach that we have in ONTOX. It's implemented as a Docker container, which provides a user interface and a backend that basically guides the user through the workflow. So it turned out it's an excellent technological match for integration in ONTOX HUB, because on one side it's easily configurable, so we can adapt it to the Opera workflow we have in ONTOX on one side, but on the other side we can also easily deploy it because it's built on a very similar set of technologies that we use in ONTOX. The other thing that we're currently working on, just mentioned it, is LLM readiness. So make models in ONTOX HUB available for integration with large language models. So this is a possibility that was absolutely not foreseeable during the conception of the ONTOX project, because nobody was really expecting large language models to take off on a that broad basis, to work that well on big scale and for all different kind of applications. And the flexible architecture of the ONTOX HUB will hopefully support this in the future, and we're collaborating with ONTOX W5 partners to facilitate that. Of course, on top, we will also like to touch more base with VHP4Safety. We learned that the technical setup is very similar, and we could see lots of interaction points there. So in short, whichever technological choices you do in your project, they should be done in a way that they support sustainability in the future. There are better and there are worse choices that can be done. I'm really happy to see that amongst the different projects we've been looking so far, different European Union projects we're collaborating with, and now also VHP4Safety. So this is actually all very much aligned and going into a similar direction. So there's really a great future we can build upon. And with that, I like to thank everybody for listening in. There's a project webpage where you can learn more, www.ontoxproject.eu. And that's my email address, jörgmarusczyk@mnam.com, in case you have more questions. And with that, I would like to hand back to Marie.
Thanks, Jörg. So we are a bit over time, and there were a few questions in the chat, but Christoph has tackled some of them. So we'll just ask the one that is remaining, and that I think you actually answered during the presentation, which was, will you use the life science AI from EOSC for the logins? I think you answered that in your technical infrastructure slide, but and I think the answer is no, if I'm
no, not yet, but I'm happy to look into it.
Okay.
There are so many things going on in the world. Yeah, can't tackle them all.
All right. Yeah, if I look, I think the other two questions were answered, and there's nothing left in the Q&A. So I think we can close here to finish a bit on time. thank you, Ozan and Jörg, for this update. The next webinar, as I mentioned at the beginning, will be about risk assessment. Will be somewhere end of November, early December. So follow the ASPIS Academy page or the VHP4Safety project on LinkedIn, and there will be some updates on that. And thank you to everyone for attending, and have a good rest of the day.
Thanks, everybody.
Thank you.
Bye.
Thank you.